All right, welcome back, everybody. For those of you that previously watched our lecture on the topic of perception, or those of you that just have wonderful memories, you might recall that I mentioned at the end of that class that what we'd start doing in the next subsequent courses or lectures is talking about a new branch of psychology called cognitive psychology. We're sort of going to do that in this lecture when we explore another topic called classical conditioning. But when we're doing this, we're sort of taking a detour that you could sort of consider one that goes around cognitive psychology for a short period of time. To understand what I'm saying here, I think we should provide some context, which I can do in the next slide. So in our last class, we spent a lot of time talking about this process of perception. It was actually a follow-up to this process called sensation, and how we're able to take things in the environment and create some type of neural signal that our mind can make sense of. The logical progression, once we've looked at how we take stuff in, is to then talk about how we react to those things. Sorry, how we react to those things that are present in our environment. Well, there's lots of ways that we could explore this reaction process. But if we look at our history of psychology, one of the first ways people tried to understand how we react to the environment around us by looking at it through the lens of what we call behaviorism. Now, oddly enough, this behavioral approach to trying to understand how we react to the world around us was originally formed as an attempt to sort of be non-controversial in psychology's attempts to study the mind. And this is because in the early 1900s, as behaviorism was forming, psychology was sort of at a crossroads where people like Sigmund Freud and Carl Jung, other big individuals in psychology's history that we'll be talking about later, were attempting to steer psychology in a direction that made it very, for better lack of the word, sexy and interesting, but not necessarily as scientific as a lot of the early psychologists were. Behaviorism was sort of the pushback on this new development in psychology. It was an attempt to understand big picture ideas about why we were doing the things we did, but in a way that still stayed with the scientific rigor that many early psychologists had established. That being said, eventually many behaviorists took this pretty far and created this world where behaviorism sort of became synonymous with the new controversial idea that our mind, our emotions, our thoughts really weren't that important. Now, what I'd like for us to do in this class is sort of tease apart those assumptions and just look at behaviorism as a whole to try to understand how we could, as psychologists, explore the reaction process through the lens of behaviorism, and in doing so, really go over some of the more critical elements to psychology that started to be used in the early 1900s. If we can do this successfully, we'll have a much better grasp of some really important things that you'll want to know moving forward. I figure one of the best places to start when talking about some of these behavioral principles that we're going to be exploring not only in this class but also the next one is just define what behaviorism is. As I mentioned, this particular approach to psychology sort of was a pushback to some of the things that were happening at the time in the early 1900s. If we want to pinpoint exactly what a behaviorist studies, what we see is that all people who call themselves behaviorists tend to focus on the observable. In particular, they tend to look at cause and effect relationships between behaviors and things that we can see in the environment. Now, what this tends to lead to is research on the process that we mentioned earlier of learning. How we're able to change our behaviors as a result of the things that we're exposed to. And this does operate on the assumption that a lot of the things that humans and other species are doing are really a byproduct merely of the things that we encounter. This thing called a stimulus-response relationship. That doesn't mean, though, and this is important to note, that all behavior stress that those internal things going on in the mind had no utility. It's not that you don't have emotions or the thoughts don't matter. It's just many early behaviorists in the 1900s suggested that since there are so many things going on inside our head that are almost impossible to quantify, and there's so many individual differences, if we could just study the observable, maybe we could make looking at this process of learning a little bit more scientific and something that was applicable to a large number of individuals. Say, for example, I wanted to understand why certain people did things when they got angry. Well, defining what anger is and why people go to different places is really challenging. So what a behaviorist might do is look at the right set of scenarios that lead to reactions that people often pair with anger. Let's say that we start talking about how, as you're moving in a specific direction, doing things towards some quantifiable goal, those things are blocked. And those blockings of that movement leads to things like yelling or increased heart rate or increased sweating or something along that line that can be quantifiable. Now, a researcher would say that those observable indicators are the things that we would consider anger. And the observable things that led to that reaction are the factors that lead to anger. And it's not saying when we talk about it in that way that you don't feel anger, that your thoughts didn't lead to the anger or certain motivations weren't the main factors behind the anger that was produced. It's just saying that by focusing only on the observable, we'll be a little bit more scientific in our study of that topic. That's at least the assumption that most behaviorists had. That it's not that these internal things don't matter, it's just, well, it's tough to really be scientific, especially at the time, if we go beyond that. Of course, not all behaviorists felt this way. In fact, as the field of behaviorism started to grow, a new branch of behaviorism started to form that early psychologists later coined radical behaviorism. It's actually a term introduced by somebody we're going to be talking about in our next class named B.F. Skinner. Radical behaviorists believed that not only should we try to study human activity and actions of the mind on this observable realm, but these things were really the only things that mattered when we looked at human behavior. We might think that thoughts and emotions and all of the different things that we consider critical components to who we are and why we do the things we do are important, but radical behaviorists argue that all the things that we do could potentially be just whittled down to a stimulus-response relationship that traces back through many years. And one of the champions of this very controversial idea was a gentleman named John B. Watson. One of my favorite quotes that I've seen attributed to him, and I'm struggling to find all the different places where this is coming from, but there's a belief that it came from a conference in 1930, is the one that you see listed here on this slide. When he said to a bunch of individuals, "Give me a dozen healthy infants, well-formed in my own specified world to bring them up in, and I'll guarantee to take any one at random and train him," nowadays he would say, train that person, "to become any type of specialist I might select. Doctor, lawyer, artist, merchant, or chief, and yes, even beggar and thief, regardless of their talents, pensions, tendencies, abilities, vocations, and race of their ancestors." Very, very broad statement, very controversial. Not including the kind of derogatory terms that he used in a couple places here, but one that really spoke to the heart of what radical behaviorists believed. Watson pushed this notion that everything about us can really be whittled down to the observable experiences that we have, and if we control those environments perfectly, like we could do in potentially a lab with certain animals, well, then we can create any type of behavior or outcome that we desire. And Watson not only would make these outlandish statements and push these things, but he spent a large portion of his career trying to prove that this was the case. One of the more classic cases that were tied to him, even though he did many experiments with a large number of animals and people over the years, was a case with a young boy named Little Baby Albert. Now, for those of you that aren't familiar with Little Baby Albert, understand that there is some controversy studying, kind of surrounding this story, but Little Baby Albert will be forever tied in our history to John Watson. As Albert came around at a time where Watson was being challenged to really prove the utility of this idea that he was pushing. So what Watson did was try to access a large number of kids at a number of places that he had access to, one of them being an infant care unit at a hospital that was near the school that he was currently working at. And when he started tinkering with kids, trying to find ones that he could use for his experiments, he stumbled across a number of kids. One in particular was Little Baby Albert, who didn't really display any abnormal fears of things or any real indicators of a specific type of personality that would be very impactful in his tests. Essentially, if we're looking at kind of early psychology terms, Baby Albert was a pretty good blank slate. So Watson started up this lab with Little Baby Albert after he had identified him, and had Little Baby Albert play with a wide range of toys. And over time, after Albert had played with a wide array of toys, he brought in this little white rat. He placed the white rat in front of Little Baby Albert, and as Little Baby Albert's attention turned to the white rat, Watson snuck up behind Albert and banged 2 pots really loud behind his head. At least I think it was 2 pots. I can't remember the specifics there. Nonetheless, regardless of what the loud noise was, there was a loud noise that occurred behind Little Baby Albert's head, and it immediately led Baby Albert to do what all children would do when a loud noise is played behind their ears, and probably all adults would do too. He got startled, he cried, he got very upset. Watson and his assistant at the time, a researcher named Rosalie Rayner, grabbed this little rat, took it away, and calmed him before returning him to the infant care unit for the day. Next day, they did the same thing. Had him play with some toys, eventually brought out the white rat, banged the 2 pots together behind his head, made him cry, eventually consoled him, and led him back to the infant care unit. This cycle persisted for an extended period of time, and eventually it got to the point where every time Watson came to get Little Baby Albert, he was a little nervous. Every time he brought out the toys, he was even more nervous. And the first second the white rat would come out, Little Baby Albert would be beside himself, trying to get away from the rat as soon as possible because he had begun to pair it with that loud banging noise behind his head. Now, much to many of our dismays, Watson was ecstatic when he started to create these results. He contended that this was proof positive that radical behaviorism really was an explanation for a lot of the different individual differences that we see amongst people. And he started to push these findings. Now, for those of you wondering about the fate of Little Baby Albert, know that, well, we don't know what quite happened to the boy. There's some reports that Little Baby Albert's mother somehow found out that it was her child that was being tested by Watson and promptly removed Baby Albert from Watson's experiments and kept him away from Watson. So there was this young boy who eventually grew up to an adult and nowadays would be over 100 years old, that theoretically, was terrified of little white rats. Probably the better of the different things that have been mentioned about Little Baby Albert. The other one is that Little Baby Albert's health might have taken a turn for the worse, not necessarily a byproduct of what Watson did, but because he was a young baby in an extended infant care unit, and there was probably other things going on with him at the time. But nonetheless, Baby Albert is forever again tied to John Watson, and the ideas that Watson pushed from this work really highlighted some of the extents that people in behaviorism went. I want us to note here that this is, again, not the extent that most behaviors go to when trying to understand humans at this level. It really was, despite what we just talked about. It is originally designed to be an attempt to make studying basic principles of the mind through what we would maybe call cognitive psychology, but in this case we call it behaviorism, on an observable level. And even this basic study that Watson did with little baby Albert could be whittled down into a very scientific formula that, ethical or not, was easily explained even when Watson was doing this. In fact, what Watson was doing at the time when he experimented with little baby Albert was utilizing the research of one of our very first behaviorists. And this behaviorist, who we're going to give a name to in the next slide, focused his attention on something that we nowadays call classical conditioning, the technique that Watson was using in his work with little baby Albert. Classical conditioning, just for context, is one of the two main forms of learning that early behaviorists focused their attention on. It's not critical that all behaviorists study how we do the things we do through just two types of learning, but it is important to note that many early behaviorists did focus their attention when trying to understand human behavior and animal behavior alike by focusing their attention on the two types of learning that you see listed here. Classical conditioning, the one we just mentioned, which is sometimes called involuntary reactionary learning, and another one called operant conditioning, which we'll be talking about in the next class, that involves voluntary responses to specific scenarios because of our attempts to get specific types of outcomes. A lot of the elements of what we're learning about can be tied to both types of conditioning, but there are nuances to each that make them very different and make them only applicable in specific situations. Hopefully, as we go through this class and define what classical conditioning is, you can not only recognize how the terms within classical conditioning works, but you can recognize the context around the situations where classical conditioning applies. So you then can, in the next class, when we start talking about operant conditioning, get those terms and start to identify the situations where operant conditioning would apply. I guess I promise both do not apply to specific situations. Usually only one will apply to a specific type of learning situation that we find ourselves in. So who was this champion of classical conditioning that we talked about earlier? Well, the individual that's credited with coming up with the introduction of classical conditioning is the gentleman you see pictured in the upper right-hand corner, named Ivan Pavlov, who spent the majority of his early career actually is looking at biological and physiological properties of the body. He spent many years trying to dissect different systems that we had. For example, he spent most of his graduate work studying the circulatory system and how blood was able to flow in different places where it didn't seem to logically make sense that it could, like all the way down to our feet, where gravity would suggest that it would be very difficult for blood to circulate in those areas. One of the other systems that he eventually started studying was the digestive system. In particular, he was very intrigued by the concept of salivation and how it was triggered and how it persisted while we were trying to break down food and get it from our mouth into our stomach. So he devised this really elaborate lab that hooked up test tubes to the salivary glands of dogs, and then he would give them varying amounts of food to see if he could come up with a model that showed and predicted how much and when a dog would salivate based on the amount of food that they were presented. But as this study started to unfold, he ran into something that he reported originally as a problem. These things that he called psychic salivations. In essence, his plan was to give the dogs varying amounts of food and measure how much they were drooling, in particular how differently they were drooling when they got different amounts. He expected that when a dog got a ton of food, they would start salivating a lot. When they got a moderate amount, they would salivate just a normal amount. And then when they got significantly less, they would just salivate a little bit, enough to break down that small amount of food and then move on. But what he kept finding was that his dogs weren't kind of obeying the plan that he had. He would bring them food, and before they could even see how much they got, they would start drooling all over the place. Again, something he called psychic salivations. And for a time, this was a source of frustration for Pavlov. He started to devise all of these different things that he could do to prevent the dogs from knowing that they were about to get food, so he could start measuring how much they were salivating based primarily on how much food they were seeing. So he'd switch up researchers, have bowls hidden in different areas, but regardless of what he did, within a few trials, the dogs would catch on to what was happening and start emitting these psychic salivations again. So eventually, he decided he was going to have to scrap this study on salivation and focus his attention on this weird thing that he had discovered called psychic salivations. And he did this with a little bit of caution. He wasn't really thrilled getting into the world of psychology in the early 1900s, primarily because of some of the controversies surrounding the field and the fact that it was just a fledgling science in comparison to biology and physiology. He decided to study it, and eventually he has become, even though he made lots of other discovery in biology and physiology afterward, he has become kind of tied to this behavioral movement for all people to kind of coming into an intro class to see. And his work on these psychic salivations and other work that subsequently looked at these concepts more became the framework for this new type of learning that we nowadays call classical conditioning. So how does this classical conditioning work? As I mentioned, classical conditioning is all about involuntary responses to stimuli. But for it to occur, you first need to have something called an unconditional reflex that's present. For the example that we talked about earlier with Pavlov, the unconditional reflex was the food being jammed into the mouths of these dogs and them naturally salivating. This is something that required no learning, no planning, no decisions. It just is an innate response to a specific stimulus. In fact, you can try this on your own if you'd like. Try putting food in your mouth and seeing if you don't salivate, or you can prevent yourself from salivating. This is just a reflexory response. We have many of them. We've got our startle responses, we have blinking responses, we have lots of reflexory responses to stimuli that persist with us throughout our life. All types of classical conditioning rely on the existence of one of these reflexory responses for it to work. Because what we need to do once we've found this unconditional reflex that we're looking to alter is then introduce something called a neutral stimulus. It's a stimulus that reliably indicates that some other stimulus following is going to produce this unconditional reflex. This neutral stimulus is then followed by the unconditional stimulus, which is again the thing that's producing the unconditional reflex. And over time, as it continues to get paired with the unconditional stimulus, it starts to produce something we call a conditioned or a conditional reflex. When that happens, we rename the neutral stimulus as what's called now a conditioned or a conditional stimulus. And this conditioned or conditional stimulus produces the same unconditional response or unconditioned response. But in this case, we call it a conditioned or a conditional response because it's in direct response to the neutral stimulus that has become a conditioned stimulus. So going back to that example with the dogs and Pavlov, the dogs had this unconditional reflex where the unconditional stimulus of food being put in their mouths was creating an unconditional response of them salivating all over the place. And over time, say a researcher, which started off as a neutral stimulus, a researcher giving them food, eventually got paired with that food, producing the unconditional reflex so much that the researcher eventually became a conditioned stimulus that produced a conditional response of salivation, the same physical response as the unconditional response. In this case, it was called a conditional response because it was salivation to the researcher. It's a lot of terms and a lot of weird math, but oddly enough, when Pavlov discovered this, it created this huge upswell in interest in this topic, and people started looking all over the world for applications to this specific idea. This basic classical conditioning formula started to be something that people were trying to see if they could apply to schools and to friendships and to worried behaviors of people displaying abnormal responses to things. In essence, it started to be the thing that everybody wanted to find a way to trace back to other things. Eventually found that there were limitations to it, but there were also a large number of applications to this basic classical conditioning formula. One of my favorite examples where we saw this really reflecting in real life is when we started to tie the topic of stress and stress reactions to environments that don't seem to intuitively be tied to them. Now, for those looking for some basic definitions, understand that a stressor is anything that produces some type of stress or anxiety reaction. But there are specific stressors that are sort of believed to be innate. Things that do automatically produce a stress reaction response regardless of what we've encountered. Say, for example, loud noises, or a need to react very quickly and specifically in a short period of time. There doesn't have to be any learning that takes place that triggers these stress reactions in the body when people encounter these stimuli or these situations. But oddly enough, what tends to happen for many of us is we start to tie specific environments to these stressful situations. And for some athletes, maybe the sound of sneakers on the floor or the air in a specific room can lead them to automatically start to associate those things with highly stressful events that are going on in their athletics. Or for people who have experienced loud noises or very combative relationships, they might start to tie specific environments, specific cues to those things that naturally produce stress. And eventually, those things that shouldn't actually have any effect on us, should be defined as neutral stimuli, start to become conditioned stimuli and produce the same stress reaction even before we encounter the stressors that we tie to them. And my guess is that all of you can find a specific example in your life that you can tie to this pairing. Now, if we were in the in-person class, we'd pause here and I'd ask everybody to pair up with somebody and describe their own thing that doesn't intuitively seem to relate to stress that does produce stressful responses, and ask each person to sort of break down how these things work. Usually about 75% of the time we get hits where people can really break things down, but we also, around 25% of the time, get some big misses. And this helps us really elaborate on what's required for us to label something as an example of classical conditioning, and what we can do when we find something linked to classical conditioning to define all the things that are going on. Since we're not in person, I encourage you to try to do this on your own. Try to look up examples of how this works and see if you can really break down not only the terms within classical conditioning, but the situations where this specific concept does seem to apply in real life. If we can do that, well, then we can take the next step to looking at how we can subtly change things, alter things, and still look at classical conditioning, but in a way that applies to even more situations. And this is exactly what people like Pavlov started to do once this idea of classical conditioning solidified. What lots of researchers that now started to call them behaviorists wanted to do when we established what classical conditioning and other types of learning were was try to find ways to really show quantifiable proof of what we were looking at when it came to learning. One of the things that people started to create are these huge volumes on things that we call learning curves, showing how responses that were transitioning from neutral responses to conditioned responses started to really emerge in people or animals being tested. Say, for example, that Pavlov experiment. What researchers would do was look at how much a dog salivated as they were being introduced to a new researcher holding food the first time, and slowly expose them more and more to that researcher holding food and measure the degree of salivation that the dog was doing every time they saw the researcher. And their argument was that as they were exposed to the researcher more and more, they'd salivate more and more, and eventually they'd get to a point where what they considered learning had occurred. And by their indication, learning occurs when the response to that neutral stimulus is exactly the same as the response to the unconditioned stimulus. That was when the neutral stimulus was officially labeled a conditioned stimulus. And what researchers found is that once that happened, learning had officially taken place, and the response, if these things continued to be paired, would be solidified from then on out. And why would we draw a whole bunch of charts on this? Well, what researchers became uniquely interested in was how we could vary different pairings and use different species to show how learning curves varied from situation to situation. And this gave us a better sense of kind of innate abilities to learn specific things and differences from animal to animal that we nowadays tie to things like intelligence and other concepts that were more cognitive in nature. Once we did this, one of the next places that Pavlov and others went was to explore this concept of what we now call forgetting. The forgetting for behaviorists is different from our layperson's terms on this. Forgetting is not about just having something erased from our heads. It's about, when we're talking about classical conditioning terms, the severance of that conditioned stimulus, or what's now become a conditioned stimulus, from the unconditioned stimulus. In this case, the conditioned stimulus is presented alone, so in the Pavlov example, the researcher comes out with the food dish, but that unconditioned stimulus that's expected to follow doesn't follow. So the researcher comes out with not food, but an empty bowl. And in this case, researchers can measure how much the dogs salivate time after time as the researcher continues to come out without the bowl of food. Or however this is designed, we measure how much conditioned stimulus starts to weaken the conditioned response as it continues to not be paired with the unconditioned stimulus. And for behavioral terms, forgetting happens in classical conditioning when that conditioned stimulus no longer produces a response whatsoever. In this case, it sort of reverts back to being a neutral stimulus. Now, obviously, that definition of forgetting is very different from other definitions you've probably heard, and in fact it's slightly different from other ones we'll use in future classes when talking about this cognitive concept. But what behaviorists were able to do with this specific approach is really highlight how we could maybe quantify the basic cognitive principles in a lab. I also talked about extinction and how long these things could last, with the assumption that when we'd forgotten to pair things, or when we'd kind of severed the tie between conditioned stimuli and unconditioned stimuli, it would last forever. The severing, I guess, would last forever. But what researchers found eventually was that this extinction is not as permanent as we had originally thought. Well, the really interesting discoveries that Pavlov and others came across was this effect called spontaneous recovery. That researcher example is actually a perfect one to highlight how this worked. Let's say Pavlov did have a research assistant continually giving one of the dogs food over and over and over again. And eventually this research assistant stopped doing that. and they were told, come in with the bowl, but don't have any food in it, and we'll just expose you to the dog over and over and over again until the dog gets to a point where they no longer salivate to you or the bowl that you're holding. I would expect that when that happens, there's no past memories of that learning experience. But what Pavlov discovered is that if, say, that same research assistant left for a month, maybe went on winter break or spring break for an extended period of time and came back, Pavlov's dogs would do a really interesting thing the next time they encountered that research assistant if they had learned at some point to pair that research assistant with food. The next time these dogs would encounter the research assistant, they'd oftentimes display what he called a spontaneous recovery, where they would start salivating all over the place to this research assistant the first time they saw them again. And this is, again, after forgetting had occurred, after they had theoretically learned to sever the tie between them and the food. And this spontaneous recovery response persisted for a short period of time. It needed its own forgetting a curve before it went away again. What was even more amazing to Pavlov and other researchers was that once learning had happened, it seemed to be easier to replicate it again. So that same research assistant was tied to food later on. The dogs wouldn't need the same amount of time to quickly tie that research assistant to the food again. And all of these things, gave us more diverse understanding of how classical conditioning worked and highlighted our ability to quantify very complex principles in cognitive psychology, or maybe we could call it behaviorism, in a way that we can really use to determine and explain how these principles worked, even if a lot of these applications were simplified and not necessarily applicable in every situation. And this led researchers to explore other aspects of classical conditioning that maybe couldn't be explained through just the basic principles of early classical conditioning that were discovered by Pavlov. One of the new tweaks that started to be examined by a number of individuals was how, in changing the pairing and timing of the neutral stimulus and unconditioned stimulus, you could produce different types of learning and different types of responses. One type of conditioning that people started to talk about was something called trace conditioning, where instead of introducing the neutral stimulus and then shortly after introducing the unconditioned stimulus, they'd introduce the neutral stimulus, take things away, and then, after a period of time, introduce the unconditioned stimulus. Say, for example, in the Pavlov research assistant case, they would have the research assistant come in, they'd leave, and then a long period of time later, food would just magically slip into the lab or the room where the dog was. What researchers wanted to see was whether or not classical conditioning could occur in these trace conditioning cases. And what they found was that eventually that neutral stimulus could become a conditioned stimulus, but it would take considerable amounts of time, especially if the pause was long. This also led to the exploration of something called delay conditioning, where instead of having the neutral stimulus introduced, then shortly after, following it by an unconditioned stimulus, you'd have the neutral stimulus introduced, have it sit there, linger for a long period of time, and eventually the unconditioned stimulus would pop up. If we want to tie it back to the research assistant example, which we've been using over and over again, imagine if the research assistant came into the room, and instead of giving the dogs food right when it walked in, the research assistant came into the room, did a bunch of different things, a bunch of different tasks, and then eventually gave the dog food. This would be an example of delayed conditioning. And the question that came up was, could this produce classical conditioning? And much like trace conditioning, it indeed could, but it took significantly longer for that neutral stimulus to become a conditioned stimulus in this example. The same thing can be said for something called simultaneous conditioning, where the neutral stimulus and the unconditioned stimulus are presented at the same time. Obviously, our example doesn't work perfectly because the research assistant can't just magically pop into a room and have food in their hands. But in other lab setups and other studies, researchers have been able to create this simultaneous conditioning. And what they've been able to show is that, much like delayed and trace conditioning, it can sort of work, but the effect is hindered by the fact that the natural succession that we talked about earlier in basic form of classical conditioning wasn't there. And this also brought us to the threshold of something else that researchers hadn't really thought of at the time. The question of what happens if the unconditioned stimulus actually precedes the neutral stimulus. This was what we nowadays call backward conditioning. And researchers looked at this. Again, not that often with the example we looked at, even though it could sort of work. Let's say, the food is presented to the dogs and then a research assistant comes in every time reliably after the food's presented. The question of will the dog salivate to that research assistant ever when they come in alone, we're asked. And what we found time and time again is that in reality, learning never really takes place in this situation. And in fact, in some cases, with fear reactions and other types of reactions, it can have sort of a backward effect, like the name implies, where if the neutral stimulus is presented on its own, there's actually a calming reaction to the stressful events because it sort of indicates that the stressful situation has passed or won't occur. And I want to highlight again that when we look at all these things, these aren't necessarily different types of conditioning. They're just different ways that the pairings of neutral stimuli and unconditioned stimuli can be put together. And each of them gives us a new understanding of how learning takes place, and they can add some complexity to examples that we use that highlight how we learn to react to things the way we do. This is also true for some other things that people started to explore when we tried to apply this to real life. Researchers realized very quickly that in labs we could control perfectly what types of stimuli people were exposed to. We could reliably, say, have the same neutral stimulus introduced over and over again. One of the questions that started to be asked was, well, what if that neutral stimulus varies in the real world? What if, an animal learns that a certain person gives them food every time it sees them, and then a person that looks somewhat like that person comes out? Will these animals respond to that slightly different person the same way as the original person that they encountered? They argued that if the animal was responding in the same way to this new person, then the animal was doing something called generalization. If they were responding differently to that new person, if they were responding in a way that indicated they weren't associating that similar person to the original one, then they were doing something called discriminating. Obviously, the concept of discrimination is different than many of you might have thought of or heard of before, but for behavioral terms, it really is kind of considered the opposite of generalization. And in many behavioral applications, it does work in a very clear way. The question is, if a new stimulus is presented to an animal, do they respond to it the same way as the original one that they've learned to classically conditionally pair with an unconditioned stimulus? And what researchers have found is, much like we talked about with learning curves and forgetting curves, results vary. Certain species are more adept at learning things than others. Certain species can generalize and discriminate more, and oddly enough, there's certain things that individuals and species seem to be more attuned to. For example, pigeons are really good at being classically conditioned to any type of visual stimuli, and they're much, much more likely to generalize when it comes to visual stimuli than they are to other types of stimuli. Rats are very good at picking up on specific tastes that are associated with specific types of outcomes. And more often than not, they're very discriminatory about specific tastes. If the taste isn't precise, isn't exact, they very rarely will generalize to a new taste. And all of these things, highlight subtle things that people started to discover when we started to break down classical conditioning more. And they also led us to explore kind of real-world applications, talking about the need for novelty and the unfamiliar, and finding the right pairing, and looking at individual differences that could be indicators of things like intelligence. And it opened up this world that again started to bloom and push people to not only call themselves behaviorists, but sometimes take some of the extremes that we talked about earlier, like the work of John Watson. I don't want to end here just by talking about Watson. I want to finish by just giving us some context. So just so we have a good bookend on this, I want to remind us that what we did in this class was look at a branch of psychology that we call behaviorism, a way of trying to understand the mind by looking at observable, overt behaviors. And it's important to understand that a lot of the behavioral ideas and concepts are in the context of cognitive psychology, but their focus on overt behaviors sort of makes it its own branch of psychology. And in this class, we spent a lot of time looking at one type of learning that behavior studied, this idea of classical conditioning, which is all about pairing things. Pairing a new stimuli with something that we'd encountered in the past that presented or caused some type of automatic response that we call an unconditional reflex. But it's important to reiterate here that even though this might have lots of applications and we might see it in lots of places, this is not something that explains all types of learning. It's not something that can be applied to every situation. Behaviorists, even Pavlov himself, recognized this early on. So what lots of people decided to do was try to explore learning in other ways beyond just classical conditioning. And in our next class, we're going to explore that journey that psychologists went on, to try to find other ways to find quantifiable, very clear concepts that explain a lot of the other things we do through learning in this behavioral lens, or I guess through this behavioral lens. For today, I think we've reached our finish line. So thank you very much for listening. Hope you're all doing well, and I hope to see you soon in our next class. Take care.